Hi everyone, welcome to chapter 19, which is all about glacial modification of terrain. So we're going to be talking about first of all, what glaciers are and how they're formed. And then we're going to talk about the erosional landforms and depositional landforms that glaciers can make. I'm actually a little more familiar with these because I grew up in a place that used to be covered by ice during the last ice age. In Southern California, we don't have any glacial landforms, but we're going to go through a lot of them. So first we want to talk about glacial ice, and here's two pictures of glaciers. One is Perito Moreno Glacier in Argentina, which I was lucky enough to visit, and the other one is Franz Josef Glacier in New Zealand, where my husband visited. So basically, how glaciers form is snow accumulates on land for years without melting at high elevations. So glaciers always begin at high elevations and high latitudes. You're not going to see a glacier obviously near the equator, and you're not going to. A glacier's end can be at sea level, but it's not forming there. And so this snow, after it accumulates, gets compacted into ice. And when it gets 150 feet thick, about there, the bottom layer of the ice changes and it goes from rigid to plastic. Now, I don't mean it actually becomes plastic, it just moves like plastic. It kind of becomes bendable from the weight of all of this pressure. And this is how glaciers can move then, which they do, and we're going to see that. And you're going to watch quite a few videos to go with this chapter. You're going to see how glaciers kind of move downhill. So this glacier is moving by pressure and or gravity. So just imagine that if you had a ball of like silly putty and you started to push on the top of it, it would start to spread out. And that's kind of what's happening with a glacier. That weight of that snow is pushing that away and pushing it downhill. So you can see here an up close of that glacier that I was just talking about. You can see that ice on the bottom. It's bluish. This is that glacial ice that's gotten very, very compacted, and it allows that bottom layer to move. So there are two types of glaciers, mountain glaciers and ice sheets. The first one, mountain glaciers, they form on top of mountains where there's a lot of snow. So here is a cruise getting close to a glacier in Alaska, which you can take a nice cruise in Alaska and get pretty close to a glacier. You can't get that close because that ice is constantly breaking off into the water. And the next type is an ice sheet, which is going to form at a very, very high latitude. So Greenland is an ice sheet, right? So you have the snow accumulating kind of in the center of that landmass and pushing out towards the sides. The terminus of a glacier can end at a very, very low altitude. So this is the terminus of that glacier in New Zealand, which is basically at the shoreline that it ends. So it gets pushed down pretty far, and it can end really, really close to the shore and at a very low elevation. But they're going to start at a higher elevation or a very high latitude. And so there's two words that you have to know is accumulation and ablation. And so the accumulation zone is where more snow is added each year. So in this picture right here, this is the accumulation zone, right? This is where the snow is being accumulated, and pushing down like that piece of silly putty that is pushing it down the hill. The ablation zone is where more snow is melted each year. So once you get out of the accumulation zone, you're going to get into an ablation zone. Even though there's still plenty of ice, we're out of that snowfall, and this ice is still melting somewhat as it goes down. If you have more accumulation than ablation, so if you're getting more snow over here than ice is melting over here, this terminus, which the terminus is the end of the glacier right here, is going to advance. And if you're getting more melting happening than you are accumulation up here, this terminus is going to retreat. And so many glaciers will advance during the winter, retreat during the summer, advance, retreat, advance, retreat. Some of our glaciers, which we'll talk about, are disappearing due to climate change, and so they're going away altogether. They might advance a little bit in the winter months, but they are retreating a lot more in the summer months. And so we're also going to talk about all of the sediment that's deposited by glaciers as they retreat, and all of these different landforms that are forming up here, which are more erosional landforms, although there are more erosional landforms down here as well, and then depositional landforms, which are definitely farther down the glacier. This glacier, though, even though this end is like retreating back, this entire thing is still moving downhill. You're going to watch a video where you can see, though, even though the terminus is going back, it's a time lapse, you can definitely tell the direction, the movement of that ice is always going downhill. Gravity always wins. And so here is a drawing of Greenland, and you can see here is our zone of accumulation in the center of the ice sheet, and here are our zones of ablation where the ice is melting off. And so this ice sheet will advance and then retreat and then advance and then retreat, depending on the seasons. We are having massive shrinking glaciers. Here is some photography taken in Alaska at 2 different intervals. So this one is probably about 50 years ago, and you can see where that glacier is now. The picture was taken at the exact same spot, and the glacier is way, way farther back than it was previously. And so we're seeing that a lot. Glacier National Park likely will not have glaciers in it in the relative near future, so we are losing a lot of these glaciers. We also had ice sheets during the last ice age about 12,000 years ago that covered a huge portion of Europe and North America, including the northern United States. And so you can see the ice sheets here came down through the Midwest. I'm from Connecticut, so we definitely had it there. But we can see evidence of glaciers. That's one of the reasons that we know about this ice, is that we can see the evidence that they left behind. And we'll talk about a little bit, like one of the reasons there's so many lakes in this region is due to glaciers. So glaciers shape the landscape by erosion. And so it does something called plucking. Basically, it breaks big rocks off and it picks them up as the ice moves. It does something called abrasion, which you can see right here. These are very typical abrasion striations made by a retreating glacier. And then they also deposit things in the landscape. They're stuff that's left behind by a slowing and a retreating glacier. And so this is a depositional glacial erratic. So these types of big stones that are just kind of sitting in the middle of nowhere that look really, really out of place, these are kind of actually pretty common in Connecticut. People just have like a big boulder in their yard in a landscape where it looks like it doesn't necessarily belong, and we're able to date and kind of match where these things come from. They come from much farther north. So as that glacier was melting and retreating, those things that it plucked up, then it just drops off. It also shapes the landscape through its meltwater. You can imagine all of that water melting, especially at the terminus of the glacier, is going to have an effect on the landscape. We've learned about how water shapes the landscape, and this glacier water is going to be no different. So here's something called glacial troughs, right? And so here is a valley that was created by a glacier. So glaciers will fill in a V-shaped valley that is created by a river. It will come down, it will scrape and abrade the sides of this, and it will form a U-shaped valley. So this is, you take something that looked like this, after a glacier has been through there, it looks like it's got this very rounded U shape. So it carves these U-shaped valleys. This includes fjords, which are at high latitudes, and long, skinny lakes. I'll show you some pictures of fjords in a minute, but these are the Finger Lakes in upstate New York. And so these are these U-shaped valleys that now have become lakes that were carved out by glaciers. Also hanging valleys from tributaries and streams. So you can see here we have this waterfall, this valley that's happening here from this ice. Now this water goes off this waterfall and drains down into what used to be this river valley. Other glacial erosional features are cirques and tarns. So a cirque is a bowl-shaped depression at high elevation, and a tarn is just the lake in that cirque. So if you've ever seen a mountaintop lake at a high elevation or high latitude, there's a good chance that that was a glacial erosional feature, right? So this glacier is just going to carve this out. It's going to push down on it and kind of create this bowl feature. But the big idea here is that glaciers erode rounded features. So unlike rivers that are carving these V-shaped valleys that is eventually going to flatten out, glacial features tend to be very, very rounded in shape. There are some erosional features that happened with mountain glaciers near the top. And so as the glacier is forming and it's up on the side here, it's going to carve out the sides of this mountain. So between these rounded shapes, you get these very, very sharp lines. Arêtes are these knife-like edges between these shapes. So here's a picture of an arête. They are former drainage divides or markers between those watersheds. And then horns are those steep-sided peaks that have been glaciated on all sides. And so you can definitely see these in the Alps. So the one in Disneyland, the Matterhorn on the left, is modeled after a real horn on the Swiss-Italian border on the right. They modeled it after it exactly. So the next time you go to Disneyland, you can wow your friends with your knowledge of how horns are formed, and that this one was modeled after one on the Swiss-Italian border. Ice sheets create also these rounded erosional features. You have these irregular shapes that are happening on relatively flat ground. So you get lots of shallow depressions that are filled with lakes and water, which you see a ton of this in Minnesota. Minnesota is the land of 10,000 lakes, and there literally is 10,000 lakes there. They're called kettle lakes. And so you have melted chunks of ice that settle and till and melt, and they leave a hole behind, and next thing you know, you get a lake. If you are so inclined, you can go on Google Maps, zoom into Minnesota. You can see tons and tons of these lakes. They're everywhere. Lakes, lakes, lakes. Also, a depositional landform created by a glacier is a moraine. And so a moraine is basically where this glacier has come and pushed all of this material like a bulldozer. So glaciers move till or earth like a bulldozer, and they retreat and they leave that material behind. So you can see here's a valley glacier, it's come down. Here's a moraine that happened just because this is where it started to retreat after it hit this point. This is called a terminal moraine, which means that this is the end, the farthest that this glacier has ever gone. We don't find a moraine past this. So this is a terminal moraine. A recessional moraine could be from a seasonal fluctuation. This one could be wiped out later on as it pushes down, if it pushes back farther down the mountain. And then you also have a lateral moraine here, right? It's also pushing up material on the sides. So a terminal moraine marks the furthest advance of that glacier. A recessional moraine is just a pause during retreat. And there are some other landforms that form. So here is that glacier, that retreating glacier. Here's a recessional moraine. Here's a terminal moraine. There are lots to know here, so try to stick with me. But the big idea is that you can tell how far a glacier advanced in what direction by looking at these features. And we'll talk about eskers and drumlins. And this includes terminal moraines, right? We could tell exactly which direction this glacier went to, how far it went, and then it retreated. So drumlins have this very, very unique shape to them. They're like this teardrop shape. And these are elongated hills of deposited material that tells us the direction of the moving ice. And so when you see drumlins, there's 3 here, they're all facing the same direction. Right? And so you can look at satellite imagery and kind of point them out and be like, oh, we have these 3 tear-shaped features in the landscape. They're all facing the right direction, the same direction rather. It's at a high latitude, and so we can conclude that this is likely deposited from a glacier. So again, you'll see lots of them, and they'll all be oriented the same way because they're oriented in the direction of the moving ice. 1, 2, 3. We also get depositional features that just happen from the water that is melting at the end of the glacier and not the glacier itself. So something called outwash plains, which these are flat areas beyond the terminus of the glacier that are just being eroded by that meltwater. They're very similar to a floodplain. And then we get something called eskers, which are these long ridges here, right? So we can see this glacial landscape, right? We've got lots of lakes happening, and this is an esker. And so an esker is basically a clogged up subglacial river. So you'll get a river that forms kind of underneath that glacier. Some water will push through, and then it gets clogged up with material. And then as the glacier retreats, you get this this remnant of that river that was underneath the glacier that then clogged up with material and dropped it down. And they are also going to run parallel to the direction of glacial movement. And that is the end of this chapter. There's a lot of really cool videos of glaciers to watch after this. I hope you enjoy them. And then you're going to move on to the last chapter of the course, which will be a little longer than the previous 2, all about coastal landscapes.